Unit 5 notes, assignment number 2. Quick review of terms that you need to know. Write these down. A parabola is a U-shaped graph, comma, going up or down, that is generated from a quadratic equation. A quadratic equation is any equation where the largest exponent is 2. Okay? Those are two definitions that you need to be very familiar with. You need to know that a parabola is always going to be a U-shaped graph. It's always going to be going up or down. They never go sideways. And it's going to be generated from a quadratic equation. And then a quadratic equation is any equation where the largest exponent is 2. Let me give you 3 quick examples of a quadratic equation, so you get the idea of what they look like. This right here is what is known as the most general quadratic equation that one could have, y equals x squared. Notice it's an equation. We have an equal sign, and typically in quadratic equations you have the variable y and the variable x, and then notice the largest exponent is 2 in this equation. Now, there's one thing that I do need to point out to you. Sometimes, instead of the variable y, you will see a representation as something like this, like f parentheses x, or you might see a representation like g parentheses x equals, say, x squared. Now, all 3 of these equations mean the same thing, okay? So the one thing is, always remember that the variable y is the same thing as the representation f parentheses x, which is the same thing as the representation g parentheses x. Those last two, the f of x, f with x, and g with x, they are just simply ways that mathematicians show the variable y. Okay, why do they do that? Because they think it's cool to do. And as we all know, mathematicians are super cool, okay? So another example of a quadratic equation, I said I'd give you 3, I lied, I'll give you 2, would be like y is equal to x to the second power plus 2x minus 3. Now notice this equation right here. If instead of y, you saw the f with the x, or if you saw, say, the g with the x, all that simply means those two representations mean the same thing as the variable y. So all 3 of these equations really are 3 different ways to represent the same equation. Either way, if you notice, every single equation's largest exponent is 2. That makes these quadratic equations. Okay, and it's this equation, y equals x squared plus 2x minus 3, that we're going to focus on today. And what we're going to learn how to do today is we're going to learn how to make a table from this equation, and then how to put that table into a graph, okay? So, strap on to your seats here, hold on to your pencils, let's go. Here's my equation. Y equals x squared plus 2x minus 3. Notice, that is a quadratic equation. I am going to eventually graph this. Quadratic equations always graph to make parabolas, which are U-shaped graphs. Okay, and I'm going to do this by making a table. So whenever you have a quadratic equation, here is what the table looks like for a quadratic equation. You draw two columns, one of the columns representing the variable x, the other column representing the variable y, and then you create 1, 2, 3, 4, 5 rows, and what you're going to do is inside each one of the rows, you are going to fill in numerical values inside each one of the rows here, okay? And we're going to put numbers in the x column, and then we're going to put numbers in the y column. I'm going to tell you what numbers to put in the x column. -1, put it right in the middle of the x column. Above -1, we're going to put 0 and 1, the two numbers bigger than -1, and then below -1, we're going to put the two values or the two numbers immediately less than -1, -2 and -3. Okay, now what we're going to do is we're going to figure out what is the very specific value that is going to go in each one of these y boxes for the corresponding x value. Okay, and how we're going to do that is we're going to use the concept of substitution. So we are going to take the equation that's given to us, y equals x to the second power plus 2x minus 3, and what we're going to do is we are going to substitute the number for x, and we're going to start with 1 in the place of the x's in the equation. So in other words, for this first row when x is 1, I'm going to rewrite the equation, but instead of writing an x, everywhere where there's an x in the equation, I'm going to substitute the number 1 in the place of that x. So you could see what I just did here. I took where the x's were and I changed them to 1. Why did I do that? Because in my table, my x value was 1. Then I am going to work out this equation. I'm going to figure out what is 1 squared plus 2 times 1 minus 3. What is that equal to? And when we work that out, that is equal to 0. Okay? So that means that y is equal to 0. So when x is 1, when I substitute 1 into my equation, the equation turns out to be equal to 0, which means that y is equal to 0. And what that has done is that has just created an ordered pair for me with the coordinates 1, 0. Okay? And what we're going to do is we're going to repeat this process 4 more times for 0, -1, -2, -3. Let's go ahead and repeat the process for 0. So I'm going to take my equation, but instead of everywhere there's an x, instead of writing x, I'm going to substitute the number 0, which is my x value from my table. So my equation is going to be y equals 0 to the second power plus 2 times 0 minus 3. Once again, you can see that everywhere where there used to be an x in my equation, the two places there used to be an x, I substituted a 0. I work this out. That is equal to 0 to the second power plus 2 times 0 minus 3. That is equal to -3. So that means y is equal to -3. So in the y column, next to the 0 in the x column, I put a -3. And that creates the ordered pair for me with the coordinates 0, -3. You get what I'm doing? Let's do it again, and let's substitute -1 in the place of x. Y equals -1 to the second power plus 2 times -1 minus 3. I'm going to work that out. So -1 to the second power plus 2 times -1 minus 3. That is actually going to be equal to, let's see, what is it? I'm going to pause. Go ahead, say it out loud. I'm listening. -4. I heard a bunch of you saying it. That was amazing. Thank you so much for participating. That means y is equal to -4. So what that does for my table is it creates the ordered pair with the coordinates -1, -4. Okay, let's do it again. Let's substitute -2. Y, my equation becomes y equals -2 to the second power plus 2 times -2 minus 3, and then I'm going to work that out and see what it equals. You should be able to work this out accurately. Now, if the one thing that I need to say is that you have to work these out accurately. If any of these y numbers are wrong, what it's going to do is it's going to mess up and not give you a parabola when you graph it. Okay, so working this out, you should get, let's see, -3. That's equal to -3. So y is -3 when x is -2. So that creates the ordered pair with the coordinates -2, -3. Okay, last one, let's substitute in -3 in the place of x. Hopefully you've noticed that every time I substituted a number where x used to be, I always put that number in parentheses. Very important. It's a necessary habit. So y equals, in parentheses, -3 to the second power. I put the parentheses with the -3 because that's where x used to be, plus 2, then in parentheses, -3. Once again, I put that -3 in parentheses because that's where an x used to be, minus 3. I work this out, -3 to the second power, that's 9. By the way, I'll show you how I'm working it out. Plus 2 times -3 is -6, minus 3, 9 plus -6 minus 3 is 0. So that creates the ordered pair with the coordinates -3, 0. Okay, so in our notes, when the title of the notes say equations to tables, we've done that. We had an equation, that was the y equals x squared plus 2x minus 3. We made a table, that's the table we just created. Now we're going to go to a graph. Okay, so what we're going to do now is we are going to take these ordered pairs right here, these 5 ordered pairs that I generated from my table that I got from my equation. I'm going to plot or graph these 5 ordered pairs on an x and a y axis. So I'm going to draw an x and a y axis here on my paper. I didn't mean to do it in purple, but I'll go with it. I'm going to, let's see, I'm going to scale. This is my x-axis right here. This is my y-axis right here. I'm going to go ahead and scale my x-axis and my y-axis out to 5 in all directions, both right, left, up, and down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, you could see from my values of my points, I really didn't have to go out to 5. My x numbers, I really only had to go out to -3 and over to +1. And my y values, I pretty much only had to go from 0 down to -4. Okay, but that's okay. So now what I'm going to do is I'm going to take these points right here. First one has coordinates 1, 0. I'm going to plot these 5 ordered pairs on my graph. Okay, so 1, 0, over 1, up 0. That's right there. All right, next point, 0, -3. 0, -3 would be 0, -3 means over 0, down 3. Right there on the y-axis. 3 down on the y-axis. Third point, -1, -4. That means I'm going to go left 1, down 4, and put a point. My fourth point is -2, -3. I'm going to go left 2, down 3. I'm going to stop right there and put a point. And then my fifth point is -3, 0, which means I go left 3, and then I stop. don't go 0. So I stop. So you could see, hopefully, that the 5 points that I plotted, they make a general form of the letter U. Okay, so you guys, when you're doing these graphs, when you plot the 5 points, if they don't make the general form of the letter U, that's telling you you did something drastically wrong. Now, the last thing that I do is I connect the points, and when I connect the points, I want to do a nice, smooth U. Do not make a V. Don't get sloppy. If you make a V, it's going to be marked wrong, and you could connect them section by section, or you could go all at one time. Okay, so I'm going like this. Not the greatest graph in the world, but you can see I've got a general form of a parabola, which is a U-shaped graph. Now, if I stopped right here, this graph would be incomplete, and therefore it would be wrong. What you need to do is you have to extend the graph past the furthest left and the furthest right point. So extend your parabola past those 2 points on the left and the right, and then you need to put arrows on the end of your parabola, because parabolas extend continuously forever, and they continuously get wider and wider and wider. Okay, so this would be my parabola. Now, some key features of this parabola. Where the green arrows are pointing at, those 2 points are what are known as the x-intercepts. You have to be able to identify the x-intercepts of a parabola. Now, this parabola happens to have 2 x-intercepts. Sometimes parabolas only have 1 x-intercept. Okay, but you have to identify them. So where the green arrows are pointing, that is what is known as the x-intercepts. Where the gray arrow is pointing, at that very bottom point, that point is known as the vertex of the parabola, and the vertex in this graph is a minimum value, okay? Remember from your notes from assignment number 1, the vertex is the lowest point on a parabola, or it could be the highest point if the parabola was going down. Okay, and then it's a minimum because nothing is lower than that vertex point right there. Okay, and one more key feature that you need to be aware of is it's where the black arrow is, the point that the black arrow is pointing at, that is what is known as the y-intercept. Okay, so these are key features that you have to know and recognize in a graph. We have this parabola has 2 x-intercepts, it has a y-intercept, and then we have the vertex at the very bottom, which would be a minimum because it's the lowest point. Okay, so there we go. Unit 5, assignment number 2's notes.